Hello everyone! In this video I will try to walk you through the process of making a simple falling sand game and show you the basic theory behind all falling sand simulations. For this project I used C++ programming language and SFML2D library for drawing. I hope that this video will encourage you to try making a simulation like this yourself. It's a great learning experience. Anyway, let's get to the video. Every falling sand simulation, such as ones in Noita or in Powder Toy, is a complex form of a cellular automata. And what exactly is a cellular automata? A cellular automata is basically a kind of a turn-based game, consisting of a grid filled with cells, where each cell follows a set of rules based on the states of all neighboring cells. A popular example of this concept is Conway's Game of Life, where just few simple rules can amount to great complexity, as seen here. With that out of the way, let's get to the actual simulation part. First off, we need to define a grid where a simulation will take place. In my case it will be 100 by 100 cells. Then, we should define the actual cell. It's a struct that holds two values, an ID number to define what element it contains, 1 for sand, 2 for water and 3 for stone, and a boolean telling us if the cell is occupied or not. Since it's a simple project, we will only work with these three basic elements and a square grid. Now to the physics part of the simulation. We'll start off with sand. Every single iteration, a sand cell first checks for a free space downwards and moves there if it finds one. This behavior simulates gravity and allows free falling. In the case that there is no available free space downwards, it checks for free space to the left or right diagonally, and if it finds one, it goes there. I added a little bit of randomness in this movement so it looks more natural. Next, we have water. Water works in a similar way to sand. First, it checks for a space downwards and moves there if it finds one. The big difference is that when there is no free space downwards, a water cell checks for free spaces to the left and right and moves there every iteration. With that, water simulates the effect of flowing and can fill up any given space. And lastly, stone. Stone is by far the easiest element to compute. It has no special behavior. It's an immovable object and it functions as a platform for other elements to interact with. As you can see, you can achieve a good looking simulation with such simple rules and just 3 elements. I certainly would like to expand on the idea in the future and make this into a bigger project. You can look at the code base on GitHub in the description down below. Hope you liked the video. Consider subscribing if you did, and see you in the next one.